Hi, my name is Thomas Norman, and today I'll be discussing our attempt at quantifying alcoholic beverage prevalence in Instagram images using a deep learning algorithm. Seeing alcohol-related content has been linked to an increase in alcohol consumption and a slew of other harms, and this is exacerbated by the proliferation of this content via social media. Measuring the prevalence of alcohol-related content online is important to understand the breadth of this issue and identify targets for interventions, but it's also challenging due to the sheer volume of images shared on platforms daily. So what we wanted to know is whether or not it's possible to measure this prevalence automatically using a deep learning algorithm. So to test this, we turned to ABIDLA, the Alcoholic Beverage Identification Deep Learning Algorithm, which was developed by my colleagues at La Trobe to predict whether images contain specific alcoholic beverages, including beer, wine, and champagne. The problem with using this algorithm in social media contexts is that the content is messy. The target of interest might not be centrally located, the color of the image might be distorted by color filters, the beverage might be obscured by something, but it was worth a try. So we decided to test how well ABIDLA's predictions about the beverage contents within the images lined up with a human's assessment. The first thing we did was identify and download Instagram images tied to a licensed event. We then did a quick scan to ensure that the image pool of 6,000 images contained alcohol and also contained images that did not have alcohol in them. A researcher then hand annotated each of these images categorically based on whether they had beer, wine, champagne, or no alcoholic beverage in them. After this, we ran the images through ABIDLA, which made predictions on the same categorical contents. When assessing the entire image pool, we found a high congruence between the assessment of the researcher and the prediction of the algorithm at 85.5%, which we thought was great. However, when focusing solely on images that did contain alcohol, we found that the model over-predicted the number of images containing alcohol by about 5.5 absolute percent, or double the number identified by the researcher. We wanted to know why this was, so after a qualitative assessment of a subsample of incongruently predicted images, we identified three core themes relevant to the false positives. Firstly, images that depicted social or party contexts were more likely to trigger a false positive. Secondly, some colours were being mistaken as beverages, such as blonde hair being mistaken as champagne. And thirdly, some textures within images were mistaken as beverages. Our primary takeaway from this is that the false positives were often a reflection of the algorithm's over-reliance on contextual cues to make predictions about the prevalence of alcoholic beverages rather than simply the beverage itself. To remedy this, what we'll need to do is retrain the algorithm on a hybrid of the original training set, as well as images that are standalone beverages to help improve solitary beverage identification and reduce false positives. If accuracy can be improved through revised development, this could pave the way for a revolution in how we assess alcohol-related content on social media platforms. Thank you.